In this lesson out of Classroom Mathematics, we are currently busy with Chapter 12, Geometry of 2D Shapes, and today we are looking at congruent triangles. Now, the definition for congruent triangles are that it is two triangles that are congruent if they have the same shape and the same size. So here are a few examples of congruent triangles. They have to be exactly the same shape and they have to be the same size. Now for an overview of what we'll be doing in this video, we will look at the conditions of congruency and then we'll look at a few examples. So the first condition is when all three sides are equal, and then the reason for it is side, side, side. So as you can see in these two triangles, AB is equal to DE, AC equal to DF, and BC equal to EF. Then we can have that two of the sides are equal and one of the angles are equal, as in the following example. So that means that triangle ABC is congruent to triangle QRP, and the reason looks as follows. You'll say side, angle, side. Then you can have two angles equal and one side. So then the condition is side, angle, angle. And an example, as you can see here, we've got these two angles, B equal to Y and then C equal to X, and then we've got one of the pair of sides that are equal, so therefore triangle ABC is congruent to triangle ZYX. Your reason will be side, angle, angle. And then finally, you can have a right angle in both of your triangles, and then the hypotenuse being equal, and then another side being equal. So therefore triangle ABC is congruent to triangle LMN, and the reason will be right angle, hypotenuse, side. So this was the four conditions and the reasons that you would give for congruency. Now next let's look at some examples. So for example 1, it says that JN and KM are straight lines. Now prove that triangle JLK is congruent to triangle NLM. So JLK is congruent to NLM. Given that JK is equal to MN, so JK is equal to MN and angle J is equal to angle N. Alright, so as we did in similarity, when we prove congruency, we have to start by stating in which triangles we're working. So we are working in triangle JLK and triangle NLM. Now, once again, we need to give three reasons. So for the first reason, we are given that JK is equal to MN. So I can state that JK is equal to MN, and my reason is that it's given. Then I can state that angle J is equal to angle N, and my reason, once again, it's given. And then finally we can see that these two angles are vertically opposite, so I can say that angle L1 is equal to L2, angle L2, vertically opposite angles. Alright, therefore triangle JLK is congruent to triangle NLM. So notice that with similarity, the three lines, with similarity they were vertically situated, and then with congruency they go horizontally. And then finally we also state our reason. So here we have a side and we have two angles, so therefore our reason is side, angle, angle. So now for example 2, in triangle PQM, so PQM, and triangle PRM, it is given that M1, angle M1 is equal to angle M2, and then and PQ is equal to PR. PQ is equal to PR. So these two sides prove that triangle PQM is congruent to triangle MRP. That's A. So let's start with A. So once again, we need to prove two triangles congruent. We start by stating we are working in triangle PQM and triangle PRM. And we need 3 reasons. So for the first reason, what is given? We're given that that angle M1 is equal to angle M2. So angle M1 is equal to angle M2. Now notice that QR is a straight line. So that, therefore, if they are equal, it would make both of them 90 degrees because that would be 180 degrees divided by 2. So this is equal to 90 degrees, each of them. And we can say that that's given. Then for number 2, we're given that PQ is equal to PR. And that's also given. And then we know that this PM is a common side. So we can state that PM is equal to PM and that it is common. Right, so therefore triangle PQM is congruent to triangle PRM. And our reason is, since we were working with a right angle, our reason is right angle, hypotenuse, and side. Alright, now for B, it says we need to show that QM is equal to MR. So QM being equal to MR. So we can start off by saying that triangle PQM is congruent to triangle PRM, as we've just proven above. And since these two are congruent, it would mean that the remaining corresponding angles are equal, and also the remaining corresponding sides would be equal. So therefore, QM will be equal to MR. Then for example 3, if AE and BD are straight lines, AE and BD, with BC equal to CD, so we have BC equal to CD, prove that triangle ABC is congruent to EDC. Alright, so once again we need to prove congruency. We start off by stating in which triangles we're working. We are working in triangle ABC and triangle EDC. So 3 reasons. Now the first reason, we are given that BC is equal to CD, and that is given. Then also it shows here that AC is equal to CE. AC is equal to CE, so that's also given. And then we have these vertically opposite angles, so angle C1 is equal to angle C2. Those are vertically opposite angles. So we have our 3 reasons. Therefore, triangle ABC is congruent to triangle EDC. Our reason, we've got 2 sides and an angle. So our reason is side, angle, side. Number B, or B. So we need to prove that AB is parallel to DE. So AB being parallel to DE. Alright, so now how are we going to do that? Since these 2 triangles are congruent, the remaining angles are equal. So that means that this angle A is equal to angle E. But we know that these 2 angles form a Z, so they are alternate angles. And since they are equal, that means that these 2 lines must be parallel. So to state that, to write that down, we're going to say that we've just proven that triangle ABC is congruent to triangle EDC. So therefore, we have that angle A is equal to angle E. But these, so we can now state that, but they are alternate angles. And since they are alternate angles, therefore, and since they are equal, therefore AB must be parallel to DE. So those were the 3 examples. And now you can do exercises 12.7 and 12.8.